Hello and welcome to my channel. In this video tutorial, we want to solve this partial fraction. So the first thing we want to do is to observe the equation or the expression, if it is a proper one or improper. Of course, this is an improper fraction. The highest degree you're having on the numerator is 4. And then if you check the denominator, even if you expand the denominator, you notice that the highest you would have is 3. The highest degree of x will be 3. So this is an improper fraction. In the introductory part of partial fraction, if you've not watched that video, maybe I'll drop the link to that video in the description of this video. So when you notice that the numerator is greater than the denominator, what you need to do first is to use the long division. So since the numerator degree is higher than that of the denominator, we first divide it. But before that, let's expand. Let's open this bracket. How do we open the bracket? X minus 1 into x squared plus 1. The expansion process will give us, if you use x to multiply by x squared, you have x cubed, and x multiplied by 1 will give just x, and minus 1 times x will give minus x squared, and minus 1 times plus 1 will give minus 1. Alright, so if you rearrange this, you have x cubed minus x squared plus x minus 1. So eventually the whole of the expression becomes 2x to the power of 4 minus 2x to the power of 3 plus 4x to the power of 2 minus 2x, all divided by, and this is a polynomial expression, same thing with the denominator. We have x cubed plus, we have here to be minus x squared plus x minus 1. Alright, so what happened then? In order for us to divide this, we need to draw something like this long division pattern. We have this to be like this. Alright, so what do we need to do? The one we call the denominator will have to be outside like this, minus x squared plus x minus 1. And then the numerator will be here, which is 2x to the power of 4 minus 2x to the power of 3 plus 4x squared minus 2x. Don't worry, the process is very simple. I'm going to make it very simple for you. So what do we need to do? The first approach is to say that x cubed go into 2x to the power of 4. How many times? It will only go 2x. How? What do we mean? If I have 2x to the power of 4, which is this, dividing x cubed, of course you know that 2 divided by 1 will be 2, and if this cancels out with this is power of 3, this is power of 4, 1x will be remaining. That's how I got this. You can see how simple it is. Then I'm going to use everything you have here to multiply by this. So if I have x cubed multiplied by 2x, that will give me 2x to the power of 4. Again, I'll use this minus x squared to multiply by 2x, and that will also give me minus 2x to the power of 3. Alright, I will still use this positive x to multiply by 2x, and that will give me plus 2x squared, and then I'll use minus 1 to multiply 2x to give me minus 2x. So what is the next thing we need to do? We need to subtract the numerator, we need to subtract this first term, or this from this, or this from this, whichever way. So if you do that, 2x to the power of 4 minus 2x to the power of 4 will give you 0. And again, when it gets to this point, where you have minus 2x squared, of course this minus will affect this to be plus, minus 2x cubed plus 2x cubed will give you 0 again. And here we have 4x squared minus 2x squared. Here will give us just 2x squared. Then here will also give us 0, minus 2x. This will affect this to be plus, and then it will evaluate to give 0. So what then is the result of this? What essentially are we going to do at this point? We're going to say that the numerator we have, which is 2x to the power of 4 minus 2x to the power of 3 plus 4x to the power of 2 minus 2x all over the denominator, which is x cubed minus x squared plus x minus 1. Of course, this will be equal to, what do we have? We have 2x and we have 2x squared, so 2x plus 2x squared. What I mean by equal to, I mean that this will be replaced with this. But how do we do that? We first of all write what we have as the numerator, or the remainder, as 2x plus, and then this one becomes the numerator, which is 2x squared, all divided by what you have at the denominator. You know that this particular one has a factorized form, which is this, so we replace that with x minus 1 into x squared plus 1. Please note that this is the same thing with this. It was like this before we expanded it to like this, so we have to return it to this initial form. We did it so that we were able to do this long division. All right, so these values you're seeing are this particular one and this particular one. So this officially now becomes the numerator. If you expand this, you notice that the highest degree now is 3 and the lowest is 2 here on the numerator. So this becomes a proper fraction. And when we want to start solving, you will leave this particular one first and resolve this. When you get the answer, then finally add up this one. So what you need to do is to leave your 2x for now. So when you leave that, what do we have? This is the original equation now, which is 2x squared all over x plus 1 into x squared, I think that is x minus 1 rather, x squared plus 1. This is a slip of pen, just clean this. So x minus 1, all right? So this is equal to, we assign this is a linear factor, so we have a constant dividing x plus 1. But this is a special case. We've not done something related to this before. But when you see the power of x associated with another constant in the brackets, the way you go about this is to bring out another constant attached with x for this, plus c is part of the rule of a partial fraction. Then you still repeat whatever it is you have at the denominator, x squared plus 1. So what I'm saying in essence is that if I have x to the power of 2 minus 5 on the denominator, and then we have something like x minus or plus 1, if this is equation, so what you need to do for this first one, you assign a all over this. A now we attach with x plus b because we're having this squared here, and then this is another question I'm just forming. Then you have x squared minus 5, then plus this goes for c all over x plus 1. Just keep that in mind. All right, so that's essentially what we did in this particular case. So the next thing we need to do is that by the time you multiply, like as usual, if you've been watching my video on this partial fraction, you notice that by the time we multiply this by the denominator, which is x plus 1 into x squared plus 1. So when we multiply this, the whole of this by this we cancel by this, and then we have 2x squared remaining, which is equal to, same thing applicable here. If this x plus 1 cancels x plus 1, what will be left is x squared plus 1, and multiplies by a will be a into x squared plus 1. All right, so again, this thing has suddenly changed to positive. Please keep in mind this is negative and this is also negative. So when this negative x minus 1 cancel out, what you have left is this, and this times a is what you're having here. Again, this here is negative, do not forget that. All right, plus the whole of this multiplies by this, meaning that this will cancel out with this. So you have bx plus c multiplying x minus 1. All right, so that's what you have. So what's the next thing we need to do at this point? Do we need to use the cover-up method, or do we need to use the equating of coefficients? If you think of cover-up method, what is the number I will replace here to make the whole of this 0? If I replace here with 1, 1 minus 1 is 0. It will only affect C, and then none of this will evaluate to give 0. That means that cover-up method can work in this case. So what we need to do is to use the method of equating of coefficients. By equating coefficients, so what we need to do at this point is to expand the problem. So we have 2x squared to be equal to, if a distributes into this, we have ax squared plus a times 1 will be a. So we are also using this to distribute into this. So bx times b, or bx times x, will give us bx squared, and bx again times minus 1 will give minus bx. Again, the c will multiply by x to give cx, and c will multiply by minus 1 to give minus c. All right, so what we need to do at this point is to collect terms here before we start doing the equating of coefficients. So 2x squared will be equal to, I can see that we have x squared here, so we can, from these 2 points, or let's write them down, ax squared plus bx squared, and we're having the one that contain x minus bx plus cx, and this one does not contain x, so we have a minus c. So 2x squared will be equal to, you can notice that x squared is common, so I could just factor out x squared and I have a plus b. Similarly, I can factor out x here and I'll have b minus c, because minus x times will give us minus bx, and minus minus here will give us plus, and x times c will give us cx plus a minus c. Alright, so the next phase of this would be, we want to equate both sides now. Now you notice that on the left hand side we have a term that contains x squared. So we just say x to x squared will be equal to x squared into a plus b. Of course, you notice that this, because they're equal, x squared can cancel out. So you have a plus b to be equal to 2. So we cannot find 2 unknown. There's nothing you can do at this point. So you can make this equation 1. Again, we have this second term, which is minus x into b minus c, and the whole of this will be equal to, on the left hand side we don't have any term that contains x, so this will be equal to 0. That means this statement is just like a model where we have if a, this is a model place. If ab is equal to 0, it means that a will be equal to 0 and b will be equal to 0. Each of them will share from this 0. So if minus x into b minus b, b minus c is equal to 0, it means minus x will be equal to 0, and also we have b minus c to be equal to 0. Alright, this is where I will leave it, and then I can make this equation 2. Then lastly, we still have the term that does not contain x at all, and that is a minus c. So a minus c does not have any term that associates with real numbers. So we just say a minus c equal to 0, and this is equation 3. Alright, so but then if, let's start with this equation 3. If a minus c is equal to 0, it literally means that a will be equal to c. By the time minus c crosses this other part, then you have a to be equal to c. If you like, you can make this equation 4. Alright, so we want to substitute c equal to b in equation 1, because this equation 2 can also give us b equal to c if minus c crosses to this part, and this can further give us equation 5. Let's put it as equation 5. So if we substitute all of this into equation 1, what is equation 1? Equation 1 has a plus b equal to 2. And if we do that, if we substitute this into equation 1, equation 5 into equation 1, anywhere you see b, you just replace it with c. So we have a plus, in place of b in equation 1, or just put it from equation 1. From equation 1, anywhere we see b, we replace it with c, and this is equal to 2. So let's make this equation 6. Also, from equation 4, we have a to be equal to c. So in place of a here, we replace it with c. Alright, so we have c plus c, and this will give us 2. Alright, so what is c plus c? This will give us 2c equal to 2. And if you divide both sides by 2, because you're looking for c, 2 will cancel this. Therefore, c will be equal to 2 divided by 2 is 1. Now we've gotten our c to be 1. It is simple. We can be able to get our a from equation 4. From equation 4, a will be equal to, in place of c, replace it with 1. So we've gotten our a. Then how do we get our b? Remember from equation 5. From equation 5, we have b to be equal to c. That means, therefore, b will be equal to, what is our c? Our c is 1. So, therefore, our a, our b, a is equal to b, which is equal to c, and the result is 1, because the value of a is 1, the value of b is 1, the value of c is 1. So, wherever we see a, b, and c, we just substitute it for 1. So, finally, we'll have the whole equation to become 2x. The original equation is 2x. If you can remember it from this original form, it's down there. We have it to be, okay, 2x to the power of 4 minus 3x to the power of that. Okay, let's write it down here. So 2x to the power of 4 minus 2x squared or cube plus 4x squared minus 2x. Alright, so that's what we have. This is dividing. The denominator we have was x minus 1. Please confirm that with what you have in your book. X squared plus 1. So this is the time you need to bring back that particular remainder we said we should leave some time ago. So this will be equal to, the remainder was 2x. So you just bring it to just add up to the final answer you have. This will add up to, what is the value of a? A was assigned for 1, and that is for x minus 1. And then this will add up to, your b is, the value of b, let's look through that expression so that we can get it properly. Okay, look at it here. Notice that a is 1, and this is x minus 1, plus b is attached to x, plus c, and then this is the denominator. So do not forget that. So what do we need to do at that point? So we just use 1. Since b is attached to c and x, so b is 1 multiplying by x plus c, they are attached together, all over, then we have x squared plus 1 on the denominator. So finally, this equation will become 2, this expression will become x plus 1 over x minus 1 plus 1 times x is x plus your c is 1. Don't forget that. Alright, this divides x squared plus 1. And this holds to be the final answer. So I hope you found this video helpful. Please consider subscribing to my YouTube channel. And for my returning subscriber, thank you very much for always coming through. And if you've not liked this video, please hit the like button, share, and drop a nice comment. That will help me grow my channel. Thank you. I'll see you in the next video. Bye.